talk about the Hall effect, named after a guy named Hall. I want to say George Hall. Let's see. Edwin Hall, 1879. Should write that down so that I should write that down so that I'm more apt to remember it. 1879. So the Hall effect comes down to what actually is causing current to flow. So if I have a wire here, and that's a thick wire, I have a wire here with a current flowing through it. Now I know that I have current flowing this way. What they did not know at the time was, is this caused by a protons moving in that direction or electrons moving in that direction? Remember, the atomic theory was still, they didn't know about the nucleus yet at this point. So it could have been positive charge flowing this way. I guess they didn't necessarily know about protons. They didn't know if it was a positive charge flowing down this way or a negative charge flowing that way. We had assumed from Franklin's day that it's a positive flow, but we did not know. Well, this is where the Hall effect comes into play. So I have my wire here, and I expose it to a magnetic field. So if I have a positive charge flowing down like that, well, I know that the force on it is QV cross B. Q is positive, so the direction really depends upon V cross B. So it's V cross B, and so the force is to the left. So V cross B. If it's positive charge, it'll go over to this side. Now, if it's a negative charge flowing into it, we can look at that negative charge two ways. That we know now the negative charge is the opposite direction of the positive charge, so I can treat that as a positive charge going down. So these would be forced over to that side. Or V cross B points to the right, but Q is negative, which flips it around, and so negative charge would be forced over there. If it's a positive charge flow, positive charges will be forced over to the left side, negative charges also forced over to the left side. So now I will either have more, in this case I'll have more negative charges over here and more positive charges over here as charges slowly drift over, or in this case I'll have more positive charges on the left side, leaving more negative charges on the right side. And so now I could then measure the potential difference between the two. If this is if V high and V low are like that, I can just take a meter, a sensitive one at that point, but a sensitive meter, and put it on both sides. You know, I can figure out which is the high side and the low side, and this is V low and this is V high. And this is the point in which we actually figured out it's negative charge flow. That is the Hall effect.